Hi, it's Gadget UK here again. Wonderful donation from Keith. I'll stick his Twitter name up there. Yeah, I can't thank him enough for this. It's a Plipbox. You might just be able to see that there on the silk screen. We'll have a close look at that board in a minute, but it's got a connection here that goes, I think, to the parallel port. I think it might be the serial port. I'm not sure. I will never remember which one's male, which one's female. It might say around there. Parallel port. Yeah, it's parallel port. So you've got parallel port adapter. There's a position here for an Arduino Nano V3s. Can put some pin header here, and then I think we've got a Nano. Is that an Arduino Nano? Yes, I think it is in there. The kit. So again, you've got the pin headers to solder on there, and a jumper thing and stuff. I'm not sure what else. And then we've got this little module here, which has got a network connection here, you know, for RJ45 for plugging in the LAN connection. I'm not sure if it has Wi-Fi as well. It may well do. No idea. So let's just open this. Let's just have a quick look. Yeah, so this one's already assembled. That's nice. And it's got a pass-through. So yeah, it has. Look, it's got long legs here. So I think what happens is we need to get the sockets installed on here. This will install on there, and then if we get the pin headers onto this piece here, that will effectively like a dip chip, and that will then plug in on top. So I'm not sure what else needs to be done here, because can you see there's something, you know, component markings and things here, so there's nothing in here to go there, so I'm not sure whether anything is required there or not. It might be if you've just got a Nano on here on its own or something, I don't know, maybe for some other project, but we'll just have a go at this anyway. We'll solder these on here first, and then we'll assemble that, connect it all up, and have a go at flashing updating the firmware on the Nano. So we'll just cut this to size. It wants to be there, like that. There we go, that's one piece. I didn't realise that connector there's not soldered on either, so we'll have to solder that on in a sec. So we'll just cut the next one. Easy way to do it is just to stack them up, and then I can make sure I get it the right size again. There we go. So we'll solder the parallel port connector on first. So I'll start by just getting some solder onto the anchor points first, actually, I think. Need an awful lot of solder for those. Should do. And if we just press it down, just make sure it's totally flat, which it is. It's like that, cool a sec. And then we'll do the opposite side. And we'll do the same thing, just make sure press it flat while we just reflow that. There we go, that's not so bad. Might just get a little bit more solder on that side actually, because it's looking a bit of a strange shape. Yeah, there we go. So the D25 parallel connectors soldered on there. So the next thing we'll do was we'll put these here, but rather than just solder them, what I'm going to do is stick this in here. Actually, we need to straighten one of the pins there. Can you see that's a bit bent? So the next thing I'm going to do is stick these on here actually, and then push them into the PCB, just because it'll make them nice and straight when we solder them. Yeah, there we go, it's going in now. So just make sure that's firmly in there. And I'm not sure if it goes this way, it doesn't really matter, because all we're doing is soldering the things here. Now you can see here, can you see it's like a slight angle? It's kind of like bent across. This is where you might need to just wobble it a little bit, just try and straighten it out. Yeah, that's not too bad profile wise. It's perhaps slanted a little bit that way, so you know you could just like say hold it and just manipulate it a little bit like that. Yeah, that's pretty straight. Yeah, so you can see that's going to be totally straight there now. So I think we'll just carefully pull this out while I solder the remaining pins. There we go. So we'll clean the flux off there in a minute, but as you can see, we've got all the solder points sort of there. I think we're going to need to power this here, because I was looking at this, I was thinking, okay, so you've got 3.3 volt regulator there, and then it suddenly dawned on me, you need to power this. I wonder where the power's coming from. Parallel port is not going to provide power, I don't think. I don't think there's a 5 volts comes out there. I'll check that, just in case there is on the Amiga, but I don't think there is. And there's a couple of jumpers here. It says like ground, 5 volts, V in, TX, RX, ground. So I think this is this here is if you want the serial chip on there to support serial comms to it, I think. But I think it'll fit this way. It would be crazy to have it overhanging that way. I don't think it does. I think it fits this way here. So let's just test that now. Yeah, there we go. It's going in nice and easy there. So that's that bit done. Got a piece of socket left there. So the next thing to do is open up the Nano, and we're just going to need to fit its legs, I think. I'm not sure what else there might be in here. A jumper, I think. Yeah, so we can pretty much do the same thing. Now the thing I'm not sure about here is which way around this goes. Well, I think it's safe to assume it's not going to be that way. I suspect it's going to be like that there. So we can do the same exact thing where we fit the legs on the underside like this. And I'm guessing it goes that way up rather than upside down. Yeah, I think it does. Pretty sure I've seen pictures of this and I'm sure it was that way. And we could just fit them in here like this. Yeah, that side's gone in, that side hasn't. Let's just try that again. If I can just take that off, let's just fit that way. Yeah, it's going in, but it's a little bit stiff. Just make sure it's flat all the way along. You can see one pin has come out there, actually. Can we get that in? It's not going to want to go in, that one, is it? Oh yeah, it is, there we go. Yeah, so you can see some fine adjustments might be required if you're going to assemble it the way I am here. But I want to do it this way because I want everything to be nice and straight. If we now get that back onto there. So I'll do the same thing, we'll just solder the corner points. Just press down on it. Let's just inspect that. Yeah, it's kind of looking a little bit towerish, isn't it? Rickety in its structure there. But, you know, you're never going to get that perfect, I don't think. You know, we could put a little bit of pressure like that there, just try and straighten that out while we solder it, but yeah, that's about as straight as that's going to get. So the other thing we need to do is get the jumper, programming jumper header on there. So that might have been easier if we'd done that at the start, actually, because you can see it's going to get a little bit fiddly. Well, it's not, but it could be if you've got a giant iron. It's just solder up one corner. I'll just push it flat. Just inspect it to make sure it is straight, which it is. One of the pins on that header was a bit bent, actually. I straightened it out before I've come to solder it on here. There we go, that's not so bad. So we're all done. We just need to remove these nuts now, because obviously, you know, the socket on the Amiga has already got them, so they stop you from inserting it. The problem with that, as you can see, the cover's going to come off. So, not really sure what to do about that. You see that? What a pain this is going to be. I mean, the alternative is to, I don't know, get a nut and secure it from the other side, but then it won't screw all the way in. So let's get a bit of IPA onto that and just brush this down. I've got the majority of the flux off with cotton buds first. So there's only two things I need to do this on. This is the first one, the main, PCB. It connects to the parallel port there. And the other one is this, because obviously we had a little bit of solder there on the top. I'm just going to flood it, and we'll just give it a bit of a brush. There isn't a massive amount of flux on there, to be fair, but I just don't want it to be sticky, and flux gets bits of dust and dirt and stuff stuck on it if you don't get rid of it. I mean, this whole adapter board really could do with some sort of 3D printed housing or something for it, really, but it'll be fine. So with regards to securing the plates here, these were obviously holding it in place there. We need to do something. A couple of thoughts I had. You could put rivets or something through there, but then it suddenly dawned on me, if I just get a normal screw with approximately the right size thread, it might be a bit stiff, there you go, it's starting to stiffen up a bit, but I think we can just carefully try and force that in. Fantastic, there we go, that'll do it. So in order to program this up, you need what I think is a mini USB cable. So I'm using the one that actually comes from my, as you can see there, PSP. It's one of the ones that's got both connectors there. It's got the one to charge the PSP, and it's got a little data transfer thing, so you can transfer data presumably to and from the PlayStation Portable. But if you just plug it in and plug it into the PC, you can see the LED illuminates. I'm using Windows 10 here, so it's automatically installing the driver. So then we've got Plipbox-0.6.zip. So I extracted the Plipbox zip there. If we go in there, you can see, now these are the folder structures I was telling you about. Amiga, if you go into that and then into bin, this is where you get your Plipbox device drivers, and you've got release 00, that's for your straight 68000, 020, 040. On an LC60 you can use the 040 version, and the 020, all those work with the 060 actually, but the LC, I was not sure whether there'd be FPU reliance on the 040 version there, but there isn't, so you can use that with an LC60. And then if we go back a couple of folders there, the AVR folder, this is where the firmware is for the Nano. So you can see we've got three different flavours. We've got Arduino, we've got Avnetio, whatever that is, and the Nano. So I've got a Nano on this particular board, so that's the firmware we'll go with. So I'll copy that into the root of E. And then you can see I've formed this command here in Notepad. Just allows you to be able to change it. Make sure you name your file. That's your file name on the end there after the colon. So you've got to name that correctly. In fact, it's missing the .hex off the end. Let's just add that on. There we go, that's correct. The only thing you need to change is the serial port. Change that to your serial port. So mine's on, I think, COM5, unless it's just changed. It may well have done that. We'll try that. And I'm just going to copy the whole thing. We'll get a command prompt up. So I've got a command window there. I was just going to try AVR Dude. If you've got AVR Dude installed properly, when you just type that, you should see the, there you go, switches and things, so you know it's working, it's in the path. And if I just right click to paste that and then press return, I know you can't quite see that, but it's, trust me, it's there. Can't open device COM5, so I think I'm mistaken, it's not COM5. Let's just have a look at devices. Now obviously this process is going to vary depending on what computer you're using. Oh, there you go, COM6. Because I'm plugging in a different USB port this time, it's on COM6. Yeah, so we're doing this obviously Windows 10. It's going to vary a little bit depending on your platform. So let's change that to COM6. Copy that again. Go back to our command line. Right click, return, and all being well. Oh, hang on a minute. Yeah, we've got an error there. Input auto detectors invalid format. So it's struggling to find the fileware. That's weird. Oh, yeah. Do you know what the problem is? Look, my path here. I'm not in the right place. If I go to E, because it's in the root of my E drive, I'll try it again. Hopefully you should see a progress bar. There you go. Can you see that progress bar at the bottom? Zoom along. So that's working now. So yeah, you've got to read what comes up just to make sure it's doing it properly. And it did a read at the end. It wrote first of all, and then it read back 100%. Verified. Fuses OK. So I'm ready to install the software now. We'll plug this into the parallel port in a minute, I'll show you that. Now you can see what I've done is I've just soldered a wire here, fly lead, to provide the 5 volts. And the reason I'm using this wire here is very close to the back of my 1200. I have the upscaler there, you know, it's one of those cheap Gondes ones, a GBS8220 or something like that. But it's got a little connection on there that I can plug this into, and that will, you know, it's 5 volts, that will power this. Now you may be wondering, why can't you power from the Amiga? Now there is a pin that provides 5 volts, and I think it's just for pull-ups. It's rated to like 100 milliamps or 50 milliamps, so it's very low. This board, as far as I understand, pulls about 300 to 350. One thing it does strike me about that is you could modify your Amiga to remove that limit, that very low current limit there. It's limited by a current limiting resistor. So if you were to remove that resistor and put a little ferrite bead or something in place of it, you could feed 5 volts through there, because 300 milliamps from this is not a massive amount. Now I don't know how easy that would be on a 1200. I guess it's just a case of finding that current limiting resistor. The other thing on a, you know, on a 500 or a 500 plus, on some of the repair videos I've done previously, you'll notice those little resistors get burnt out. It's like a 47 ohm or something, isn't it? And they get burned up. And that's why someone's plugged something, not necessarily this, but something in the past that uses the 5 volt pin, and it's pulled too much current, and that resistor gets super hot. So, but it's the similar thing. You could remove the resistor on those 500s and either put a wire link across it or a ferrite bead. Ferrite bead's a better idea, I think. And an extra 300 milliamps, as long as your power supply is a good one, you should be okay. So I might revisit at some point, because you know what, having that wire coming off the back is super annoying. And of course the alternative is to, I think, feed here with you know, a 5 volt charger. Anyway, you can see the parallel port back there, so we just need to just carefully line it up and push it on. So of course this would be better if this was housed. It's going to be static sensitive, you know, you touch these pins and things here with your fingers when you're around the back. You could feed static electricity in there, kill the CAA. So it's the sort of thing you need to be careful about disconnecting and reconnecting. Never connect that while it's on, do it while it's off. Touch a radiator or something, you know, wear an ESD wrist strap if you can when you're connecting it up, and then just don't go near it once you've connected the Ethernet cable. And the Ethernet cable just plugs in there. I'll show you that when we go back over to the desk and actually use this in a minute. Now, I've already spent some time setting up the software, and it's been painful, absolutely painful, but I'll show you exactly what was required and talk about some of the issues I had. So there are a few things that can make something like this easier to set up. Now, the 1200, you've got the PCM-CIA adapter on the side, so if you've got, you know, that one of those and a compact flash card and a compact flash adapter for the PC, you know, a media adapter, USB to media, that's what they're generally called, and those will support compact flash and SD cards and things. Then you can transfer files easily between the Amiga and the PC. So I'll post the links down below, but the latest version of the source code is 0.06. Inside that zip are some binaries. There's a couple of folders. There's an AVR folder that contains the .bin. You saw me program that earlier. There's also an Amiga folder that contains another bin folder, and inside there is the, or R I should say, the drivers. So if I go into System, the first thing you want to do is go into Devs and create a folder called Networks. I'm not sure that's created automatically by any other process here, so yeah, create a folder called Networks. And in the that folder I mentioned, Amiga bin, inside the zip there for the Plipbox code, you'll find a Plipbox device, and there's 3 of them. There's one for the 020, in fact there's multiple, there's some test ones as well, but if you look at the release ones, there are 3 release ones, and there'll be one for the standard 68,000, I think, 020 and 040. Now I'm using the Terrible Fire TF1260 here, and I've got an LC60 CPU, so I tried the 020 one, the 020 Plipbox device here initially, and then I tried the 040, and I've left it with the 040. Both of those work okay with an LC60 processor. And you just have to just pick the one you want, copy it into here and rename it. You know, I think it ends in like .device, and then it says like _release 040 or _release 020 or something like that. You just rename it. The next thing I did then was install Roadshow, which I just went, you know, next. You can do the demo. The demo will pop up a nag screen that you know, lets you know every now and again that it is a demo and it's limited, it's not got as good performance. But I registered the full version. I think it's about 25 euros or something. But performance-wise, nothing I don't think is faster than Roadshow. You can use, what's the other one called, Miami, and I think there's another one that's free as well, but they're nowhere near as good. So I would, if you're going to use your Amiga with the internet, I would invest the €25 and buy a download copy of Roadshow. So once Roadshow's installed, it puts, I think, the net interfaces and the internet folder, these will be here. But in net interfaces, this is the next step. This folder will be empty. You can see here I've got Plipbox. Now I'll talk about where that came from, that file. You go into storage, I think it is, hang on. Yeah, you go into storage and you go into net interfaces, and here are some templates, and I think one of the examples, the tutorial suggests using the 3C589, but I went with, which one did I go with? I think I went with the CNET one there, but I think it doesn't really matter. So you can either use 3C589 or CNET, and you want to, I'll show you, just close that, open devs again, open net interfaces. So there's my Plipbox one, and I'll just demonstrate if I close these other windows because they're blooming annoying. Yeah, so hopefully you know where we are here, from following what the steps I've just done. And I'll show you, you just drag CNET from storage into there. In fact, it's moved it, hasn't it? I think I copied it and then renamed it and stuff. But yeah, you can copy it in there like that, rename it to Plipbox, and then you need to edit it. Now, because I've got an editor here again on the actions thing, it's dead easy for me, but you'd need to go to command line. I'll show you. Let's just do that. So we need to go cd devs, I think. dir, I've forgotten the name of the folder already, net interfaces, isn't it? dir, there, see, there's my Plipbox one. So you'd have to go edit, Plipbox, return, and you can see there we're in the editor. If I just scroll this down a little bit. So I'll perhaps zoom in a bit further when I edit this, but you can see at the top there, you've got to change that first of all to device plipbox.device. That will default to something else, so you need to change it to match the name of the device that you copied into the devs networks folder earlier. Everything else there you can leave the same. Now here's the important bit. If you're not using DHCP, if you're using a static IP address, and I am, you specify your address there. I think there's probably a hash in front of that, commenting that out. Same with the net mask. Gateway was something I was trialing, that's commented out at the moment, so ignore that. But you do need to set address and net mask if you're not using DHCP. If you want to use DHCP, which will automatically give you an IP address and stuff, you just have this line here. This is how this defaults. It defaults with configure equals DHCP. But you can see I've got a hash there in front of it. It's commented out that line because I want to use a static IP address. And then I think if we just scroll a little bit further down here, I usually use the other editor, so I'm not familiar with this one as much. Everything else in there you don't need to change. So if you are using this editor this way, to save it you would do escape and then press X, and when you press return that will save the changes. So that's that bit done. So far we've got Roadshow installed, we've copied the driver into networks, the Plipbox.device, renamed it, didn't we? And then we've got the net interfaces folder. We copied a file from storage net interfaces using one of these, either CNET or 3C589 as a template. We copied it in there and then we edited it and we've changed the IP address and the subnet mask. And then the final thing you'll want to do, because the next step I was like, where do you set the gateway and your DNS servers? How does this machine know where my router is? Because my router does all of the DNS resolution for everything. So without that, you wouldn't be able to see the internet and stuff. So the next step, go back into system, we go back into devs again. It's nearly all in devs. You've got to remember that everything's in devs. That's the easy way to find everything. Apart from when you need to copy that net interfaces file, you need to copy that from storage, which isn't in devs. It's in the it's a lower level or higher level, I should say. So if we go now into internet, this is where you set your router, and it's in routes. So I'm going to edit that. Now bear in mind you can do it with the command prompt. I'm just using the easy way for me here, which is to right click and choose edit. And in here you add a line that says defaults, leave a space, and then put the IP address of your router. And that's it. That is all you need to do. There's one other thing, I'll show you that as well. The DNS resolution. Sometimes see on my network, I find with Windows devices it happens automatically. As soon as I point them to the router, it just works. But I wasn't sure about this, so I did it here anyway. What you should do really, which is to specify the individual DNS service. So we edit the name resolution file that's in that same folder, and you can see here you just specify however many name servers you've got. So I'm with BT, and there we go, we've got the 2 different name servers there for BT. If you're not sure what the IP of those is, you can just search in Google, you know, search for, in my case, BT name servers, or BT DS servers, and it'll say primary is that, secondary is that, and there are others as well that you could add. And I think that's it. If we just scroll down there, there's nothing else here. I changed something down here that said, at the bottom, you can see that line down here that I changed said prefer dynamic, and I commented that out and put prefer static. I'm not really sure whether that's needed, but that's one of the things I did whilst I was testing the stuff here. And that should be it. Now, I've not got this connected to the network at the moment. If I get a shell up, you can do some basic things. You know, one of my machines on my network is my router, so I could go ping 192.168.0.12. That's the IP address of my router. And if this was working, we would get a response. But at the moment, I am not plugged into the network. So you'll see, it'll just literally hang there for a minute and then time out. Or say, yeah, unknown error code, look. I'll do Control-C to break that. So you want to do a test like that to see if you can see your router. Once you can see your router and you're getting a response back from it, and it'll tell you how many milliseconds it's taking to respond to the packet there, then you know you're good to go online with other stuff. And I'll show you a few programs that I've installed on here that work on the internet. One of them is a browser, IBrowse. I've gone with the registered version of that. That's about £35. It's a lot of money, but I can use it on my other Amigas. I'm not just limited to putting it on this one. I could put it on my 2000 and my 4000 if I ever connect those to the internet. But it's up to date. It's an up-to-date browser. Now, it doesn't. It's obviously very slow. You need a very fast processor. You're going to be very limited what you can do. But for me, I'm just going to be using it with Aminet and stuff, and light websites like that. I can show you that when we go back to the desk in a minute and test it. Now, with the 0.6 device driver, the Plipbox.device, the one we renamed right at the start, there's an issue with that. The burst, I think that firmware, you make use of something called burst mode, and the burst mode, I think, is not compatible for one reason or other. I'm not sure why. So you've got to disable burst mode. Now, there are examples out there, people saying what you need to do is you need to create a file. I'm trying to think what it's called now. You get a CLI up like this, command line, a shell, and you go into env-arc. Hang on, it's colon, isn't it? Yeah, so you can see here we've gone into env-archive, and if I do a dir, yeah, what you need to do is make a directory. I forget how you do it now. Is it make dir or something like that? You need to make a directory in there called SANA2, and if I go into cd SANA2 and see what's in there, because I've done this already, but that SANA2 folder will not exist on your machine. And you can see in that SANA2 folder there, I've got plipbox.config. The way you do that is to create it yourself. You just go echo, and then you do no burst pipe, into, and then you give it the file name plipbox.config, and then press return, and it will create that file. I'm not going to do that. It will create that file, and inside it will put no burst. I can show you that. We can edit it. If I do edit plipbox.config, press return. So you can see that command, that it would have just created that file with that in it. That's all it is. And that device driver, when it loads, it looks for that file, and that then switches the no burst off, which means that the 0.06 plipbox.device works fine with the 0.6 firmware on an Amiga without an issue. So the problem that I saw people having with this, and I had exactly the same problem, is the example that was given to fix the issue and make the 0.6 Plipbox device work was to do this, to do echo no burst. So it's exactly what we were doing a minute ago, but there's a difference. Piping it into and then putting the full path here. So env-arc:/sana2 /plip. Hang on, can't spell it. Plipbox.config. Yeah. And if you try that, that will not work. And the reason that won't work is because inside the env-arc volume, the folder there, directory, SANA2, doesn't exist. And it will just say path does not exist or couldn't create it or something. And that, I think, is why lots of people have not got this to work. They didn't realise that the example that had been given wouldn't work. You do need to create that folder first. So here's the upscaler I was talking about. I've got a video on that as well. I need to do a mod to this. I'll be a later one. It's covered in dust and it's dusting. But you can see the power plugged in there. And it's important to power this on first before the Amiga. So if I now power the Amiga on, so you can see I've got a fault on here. This might be another video. See this blue line? It really annoys me. It's like you mess with the top here, or sometimes just bang the screen. Look, it's gone. Right, so booted successfully. There's a repair of this Amiga coming up on my channel as well, actually, and a recap. So I can show you. So I talked about the setup and stuff earlier on. I could show you. End up with a roadshow folder, which has just literally got the manuals and instructions and things in there. That's what you end up with at the end of installation of that. And there are a few things I can do here. So I've got IBrowse. As I say, I've registered this full version. So and as you can see, we have Google coming up. Not sure why that image there, there you go. It took a while for that image to come up. But as you can see, my Amiga is on the internet. It's amazing, absolutely amazing. If I just type in gadget UK164, I might type here. I might find myself on there. Let's have a look. Of course, I can't watch YouTube videos and things, but there, yeah, I've come back in the results there. Why does they say Inspector Gadget 164? That's really weird. So one thing I would say, as you can see, it's a little bit slow, without a doubt. In fact, on the search results there, because that page was quite big, it took a while bringing back the results there. But anyway, there I am, Retro Gaming Repairs and Mods YouTube channel. And even with the latest version of this browser, it's not very good. You know, the table stuff and layout of the screen and stuff. It's just not what you would expect of a modern browser. It kind of just like puts everything all over the place. But you can use it for basic things. I've got a few links here. One of the more common ones I use with this now, I've been using it quite a bit, used it a lot last night, is Aminet. So if I just click on that, give it a second, and it's using HTTPS here. You can see at the bottom it's 256-bit. The SSL connection there, the certificate or the cipher. And if we just scroll down a bit, you can see it's more than usable. It's a little bit jerky, it's a little bit slow. The processor that I'm using at the moment is running at 62.5 megahertz. It's an 060 LC processor. So if you've got a full 68060 with an FPU and stuff, you're probably going to get better performance. In fact, you will have better performance, it goes without saying. The other thing I had to do to get SSL working properly with the latest version of this browser, IBrowse, the same company that produces IBrowse provide like a set of SSL libraries or something. It's just a single download you can download, and the very latest version of that's free to download. If you install that as well, all of the latest SSL stuff seems to work. So every website I've been to has worked, but there are some websites you just wouldn't want to go to. And I tried going to YouTube before. It's so slow. It takes like about 5 minutes just to start to display the page, and then it kind of freezes. There's just too much content there for it, too much in the way of JavaScript and stuff that it just can't handle. But from here, I could literally just have a look at something on here. Tanks Fury ADF. So I could click on that, and I think that will just download it. Yeah, there we go. So I've got the file dialog thing here, and you can see that line's about. Look, it drives me nuts. After it's warmed up, that line disappears completely. If we go into volumes, let's just stick it on T. That's in the RAM disk. Click OK. So you can see here, it's downloading completed percentage. Tells you how many. I thought it showed you how many K per second, but yeah, it's 901K, isn't it? 416K so far, 483, 521. It's about between 35 or 36K and about 40 something K per second. It's not very fast, but for things like this, and you can see that's nearly done. What did that take? About 10 to 15 seconds. So yeah, it's kind of like going back in time. It's kind of like using dial-up to a degree. But yeah, I'm very, very pleased. I'm not sure the colours are coming out right there because of the angle of the screen, but yeah, hopefully you could see what I was demonstrating there. And of course I can now just close my browser and go to my RAM disk, and I've got my download. It should be an ADF, I think. There it is, Tanks Fury ADF. So yeah, absolutely brilliant. The other thing I'll just show you briefly here, I can't really demonstrate it, is this Infinity, is it called Infinity something? Let's have a look. Infinity Music Player. So this is really cool. You can see the lines bobbing up and down here. You won't be able to hear the sound because I haven't got sound connected to anything other than my headphones, But this is like a mod, tracker player. It's internet based. You can see on the left here all this chat, there's various people. It says there Gadget UK joined. I've just joined, that's my nick on here. It's a bit like IRC, it probably is a form of IRC, Internet Relay Chat. So I could put hi on there and it comes up here. In fact, I think you've got to do command/me hi and press return. And then, yeah, it comes up there saying hello. So yeah, the song name is displayed up here. This is, like I say, from the internet. It's just completely internet based. I can choose skip, and if you watch up here, ignore the blue line. There you go. It's gone straight onto another track, and it's playing that track. So you get SID files on here, mod files, and various other file formats that it seems to be able to apply. If I just skip to the next one, one or two of these. There you go. That's a larger one. Can you see we've got a percentage bar coming across here? Shows you how big the file is. It even shows you how many 28k bits per second there. So yeah, not very fast, but I love it. It's absolutely brilliant. And you can see down there, I've just had a reply from Mario. Hi Mario. Hi, just filming a video of this. There we go. It's forever recorded. And you can do all sorts of stuff with this. It's amazing how many features and things there are. I mean, if I type /help, you get a whole list of commands here. You can search for a particular song. I can do /find. I don't know, let's do bubble. Let's see if anything's in bubble bobble, for example. And you get any of the file names there. There you go, bubblebobble.mod. And from there, I could just literally click on it. And up here, it should now load. There you go, bubble bobble. And you can see the bars bouncing along here. It's obviously a mod file from the Amiga version, perhaps. And if I put the headphones nearby, you may be able to hear it. Very cool. Yeah, so that blue line, it will be another repair. It's annoying to me, I'm going to have to fix it. And you can see AMI SSL, that's the SSL stuff you need. It's on the same website as IBrowse. IBrowse was about £35, I think, which is a lot of money for a browser, but there's very few of these things around, so I'm quite happy to support people like that, developers like that. If it brings us new versions of IBrowse with new features and stuff, moving forward, that's great. So I'm sorry the footage there of the Amiga capture was really fuzzy on both TVs here and stuff. It's just been so dark and overcast here, the lighting's been awful. But hopefully you understood and could see roughly what I was trying to show you. So yeah, talking about the 5V feed to the parallel ports. Is that one the parallel port? Or is that one the parallel port? Anyway, whichever one the parallel port is on here, on this 500, you can see these 47 ohm resistors at the back here. You just need to work out which is the one that goes to the 5V pull-up ports there, and as I say, just bridge it, and all you're doing then is connecting the main 5V rail to that. Obviously you need to be careful moving forward what you plug in there, but you could in theory power this that way. You may need to just do a mod solder from the 5V connection there to the relevant pin on here, wherever that is, but you could power it directly from your Amiga. There's no reason why you couldn't do that. I also had a look on Amiga PCB Explorer. There's also an equivalent of a 47 ohm resistor, and it sits on the top on the 1200 motherboard, and it's a larger component, I think, for the wattage. So you could do the same there. One of the things I mentioned was sticking a ferrite bead. I don't think I'd use a piece of wire. Use a ferrite bead, or because ferrite beads are going to have a limited current. You can get them in certain current ratings, just like you do resistors. The alternative would be to stick a fuse across there. Actually, you could do that. You could just get a low, I don't know, half an amp fuse or something like that. And that would do the same sort of job. Anyway, I'd like to give a special thanks to Keith McGurr for sending this. I kid you not, I've been sat on this since October or November 2019. I just haven't had a minute. I built it fairly soon after he sent it, but the software setup was the thing that was worrying me a little bit. I wasn't really sure what would be required, and I spent incredible time yesterday setting this up. It's probably took the best part of about 2 or 3 hours from start to finish to get all of the software working properly. Anyway, I do hope you found the video interesting. Please like, share, subscribe. If you'd like to support the channel, please see the Coffee and Patreon links down below. I'll catch you in the next video.